Geotechnical Engineering, Part A, Soil Mechanics, Chapter 7, Permeability, Equivalent Hydraulic Conductivity in Stratified Soil. We want to calculate the equivalent K in horizontal flow direction. Let's see how we can approach this problem. So we want to determine the equivalent hydraulic conductivity of soil in horizontal flow direction, KH equivalent. So if we have a soil consists of three different layers of H1, H2, and H3, considering a total height of H and a horizontal total flow of capital Q is passing through a these three layers. So we can easily know that we have a Q1, Q is divided to plus Q2 flow in second layer and also Q3. At the same time, we do know that I, which is hydraulic gradient, is delta H. The total head loss for each layer over delta L is the same for all layers. Let's see how is that. So if we just construct the flow net, blue lines stands for flow channels. These are our flow channels, and these vertical lines stand for isopotential lines. These vertical lines stands for isopotential lines, and the horizontal one stand for flow channels. So if we just consider a 2 point like A1 and A2, which both of them stands on the same isopotential line, it just means if you want to know what is the head of water in point A based off a reference, for example, here at the top, point A has this much of height of water from our base, which is again very, just assume this is our base. Isopotential line, it means every point stands on this line should has the same amount of water head. So if we just have a piezometer measure the head of water, you can easily see it just has the same amount of head, total head, based off our reference or base. The same story applies to the other isopotential, like which B1 and B2 stand there. So this is like, for example, H prime. If you just go for B2 based off our reference, you can see the same amount of water stand and at these two lines. And definitely from A to B, either of them A1 to B1, can have this much of total head loss in our travel. So let's see if we want to travel from A1 to B1. This is our delta L, and we can define I, which is total head loss over the length of our travel. I is our hydraulic gradient, which means the change of total head of water over length which we travel from A1 to B1. If you can consider in the second layer, this is our first layer, for example, consider the same concept from A2 to B2, we do have the same amount of length. So this was A1 and I1, I2 is delta H. Again, from A2 to B2 over the same amount of length, because the length remains the same in both of layers. And if you want to see what is the drop from A1 to B1, so this is A1 and this is B1. So this is again delta HAB. So that's delta HAB. And if you want to see what is the head loss from A2 to B2, again, this is delta I2 is delta HB delta LAB. A2B is equal to A1B1. Just says I hydraulic gradient remains the same in each layer in horizontal flow direction. If you have a horizontal flow direction, it remains the same for all layers. So again, can say the main assumption of horizontal flow is Q is divided to Q1, Q2 plus blah 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 Qn. The total Q just divided in different branches of flow, and also hydraulic gradient remains the same in all layers. So if I1 is again equal to this amount, same like I2 delta H, A1 B1 delta H, A2 same amount of length gives us the hydraulic gradient. So the first equation in our main assumption comes from continuity equation, which fluid is just divided to different branches, and the other one it just comes from our drawing, which just says hydraulic gradient remains the same in horizontal flow condition. So if that's the case, and we can also, if we just have a cross section of our section, like if this is total H, we can say area is B times H. If we just consider the width of our flow is just something like a unity, it's a unit 1, each area it just turns into A times 1 times H. And also we do know Q discharge is equal to area times velocity of our flow, incoming flow, so it just turns to H times velocity, height, total height times the velocity of our flow. And we do also velocity is equal to K times I. K is hydraulic conductivity, I is hydraulic gradient. So H times total height times equivalent horizontal soil conductivity times equivalent hydraulic gradient is equal to K1 H1 I1 plus K2 H2 I blah 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 to the last one is the summation of all of them. And we also know I is equal to is identical in all the layers. So if we just take I out of the equation and cancel it out and rearrange the equation, it just gives us KH equivalent horizontal equivalent. The hydraulic conductivity is equal to 1 over H, 1 over total height of soil of all layers times K1 H1 plus K2 H2 plus blah 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 plus Kn Hn. That's all horizontal, equivalent horizontal soil hydraulic conductivity in horizontal flow condition. In next video, we'll talk about the vertical hydraulic conductivity, and we solve some problems, example